Hi guys, good morning. Can you hear me? Hello. Can you hear me?
Yes, sir.
Yeah, thank you. Yeah, we'll start session. So Java introduction. Yes. So previous class, yes, in yesterday's class, yes, discussed about introduction to software. Just introduction discussed. Yes, like introduction. So what is software? Next, what is system software? Next, application software discussed. Yes, what is OS discussed? About OS discussed. Next, yes, application software front-end, back-end discussed. Front-end language package discussed here. Low-level and high-level language discussed. Next, generation of language discussed. Next, about interpreter and compiler discussed. Yes, what is Java? Depends on both. Java depends on both interpreter and compiler. So Java depending on both. Yes, same. Yes, what we discussed. Yes, in yesterday's class, same. It's there in document as is. Clearly, very clearly, it's there in document here. Java depends on both compiler as well as interpreter. Yes, in Java errors checking by the compiler. Java errors checking by the compiler. If no errors, then Java compiler generates dot class file. Okay. If no errors, then Java compiler generates dot class file. Yes, dot class file is a bytecode file. Dot class file is bytecode file. Java runtime by the interpreter. Java runtime by the interpreter. Okay. See, source code dot Java source code. Yes, given to Java compiler generates bytecode file. So first source code converts into bytecode file. Yes, yesterday we discussed source code converts into bytecode file. Java compiler. Java compiler converts source code to bytecode file. Okay, after that, here that is given to interpreter. Now interpreter converting bytecode to binary code, then submit to processor. See source code to bytecode to binary code, then processor, and output is like this. Okay, so first is source code converts into bytecode. Bytecode converts into binary code. Then binary code submitted to processor and getting outputs here. Finally getting outputs. Finally getting outputs. Okay. Yes. Source code to bytecode by the compiler. Bytecode to binary code by the interpreter. So Java runtime is interpreter based. Java depending on both. Java depending on both compiler as well as interpreter. So Java runtime is an interpreter based. Java runtime is interpreter based. Yes, any language runtime interpreter based no exe file concept here. Any language runtime is an interpreter based no exe file here. Okay. See here, since Java runtime is interpreter based, no exe file concept in Java. No exe file concept in Java. Same point yesterday we have discussed. Same point yesterday discussed here. Okay. So any language runtime is interpreter based, no exe file here. Yes, since Java runtime is an interpreter based, no exe file. No exe file in Java here. Here question is, can we create exe file in Java? No, we can't create. Okay. See, Java depending on both compiler as well as interpreter. See, here, for example, HTML is interpreter based language. All scripting language interpreter. Okay. Next, programming language like C, C++, and .NET, CS, they're compiler based. So these are interpreter based languages. These are compiler based languages. These are interpreter based and these are compiler. Well, yes, Java depending on both interpreter as well as compiler. Java depending on both interpreter as well as compiler here. See in Java what happens here? First is source code conversion to bytecode. Yes, bytecode conversion to binary codes. Once getting binary codes, yes, source code to bytecode to binary codes. That binary code submitted to processor and generating output, right? Yes. So why bytecodes introduced in Java to make the Java as independent platform? So why bytecode introduced? Yes, to make the Java as independent platform. See any other language except Java, any other case, source code directly conversion to binary code. Any other language, maybe C language, C++, .NET, any other language here, source code directly converts into binary code, source code to binary code. So directly only one step. But in Java, source code converts into bytecode. That bytecode converts into binary code. Okay, source code to bytecode. Next, bytecode to binary code. After getting binary code, submitted to processor generating output. Just generating output of Java program. That's it. Source code to bytecode by the compiler, Java compiler. See, Java compiler checking for all syntax errors. See, Java, yes, error checking by the compiler. If no errors, then Java compiler generates dot class file. Java compiler generates dot class file. So dot class file is a bytecode file. Okay. So error checking by the compiler. So first step one, source code to bytecode by the compiler. Source to bytecode by the compiler. Second step, bytecode to binary code. Binary code is a system understandable language, right? So bytecode to binary code by the interpreter. So Java depending on both here. Okay. So Java, yes, Java. So Java depending on both compiler as well as interpreter. Java depending on both compiler as well as interpreter. Okay. See, error checking by the compiler but runtime by the interpreter. Java runtime is an interpreter based. Okay. See, any language runtime is interpreter based, no exe file. See, Java runtime is an interpreter based. Yes, any language runtime is interpreter based, no exe file. Any language runtime is an interpreter based, no exe file here. See, these are the interpreter based languages. HTML, no exe file. Perl scripting, no exe file. JavaScript, no exe. Python, no exe. Shell script, no exe files. These cases, no exe files. Right? Yes, even Java is interpreter based. Okay. See, try to understand this point here. You try to understand. Any language runtime interpreter based, no exe file. See, Java runtime is interpreter based. Java runtime is interpreter based here. Any language runtime is interpreter based, no exe file concept here, no exe file. Since Java runtime is interpreter based, no exe file concept in Java. That's it. Okay. I think this point is very clear, right? Any language runtime is interpreter based. Any language runtime is an interpreter based. No exe file concept. Okay. Yes, since Java runtime is interpreter based, no exe file concept in Java. There is no concept of exe files. Okay. Yeah. Bytecode, binary code we'll discuss. Wait. Yes, after finishing first application development here, we'll discuss about bytecode, binary code. Exactly what is bytecode, what is binary code, we'll discuss. Yes, we have separate topic and bytecode. What is exactly bytecode? Binary code means zeros, ones. Zeros and ones is a binary code. Zeros, ones. It's a binary code, system understandable language. What is exactly bytecode, we'll discuss. Wait. Separate topic is that time I'll explain. Okay. Now here, so based on this here, now can we create exe file in Java? No. Yeah, there is no concept of exe files in Java. In Java, yes, everything is dot class file. Okay. Yes. See, no, there is no. Yes. Yeah, there is no. Yeah, there is no concept of. There is no concept of exe files. exe files in Java. There is no concept of exe files in Java. Okay. Yes, in Java, everything, in Java, everything is a dot class file. Everything is a dot class file. Okay. Everything is a dot class file. See, dot class file, yes, is not an exe file. Dot class file is not an exe file. Dot class is not an exe file. Exe file is different. Dot class file is different here. Okay, there is no concept of exe file in Java. So in Java, everything is a dot class file. Everything is a dot class file. But dot class file is not an exe file. Dot class file is not exe file. Okay. Yes. So fine. So this is just introduction to Java. Okay. So you get Java depending on both interpreter as well as compiler. Now let us start with Java features here. Java features. Java features. What are the features of Java? So this topic. Yes, independent of platform, portability, OOPS language, scalability, and security. These features, let us see one by one. First one about independent of platform. Independent of platform. Independent of platform. Let us see this. Yes, now question is here, how Java made us independent of platform? Question is, so 1 second. First of all, yes, what is platform? First question is, what is platform? Okay. Next, how Java made us independent of platform? First question is, what is platform? First question is, what is platform? Yes, how Java made us independent of platform. Independent of platform. Okay, there are two questions in this. Okay, these two questions we should answer. So first, what is a platform? So what is a platform? Platform means operating system. Platform means it's a OS. So platform means it's an operating system. Answer is simple. Answer is OS. It's an operating system. It's an operating system. It's an operating system. It's an operating system. So here, independent of platform means independent of operating system. Okay, Java is independent of OS here. Java is an independent of OS. Independent of operating system. So platform is, what is platform? Platform is OS. Java is independent of operating system. Okay, Java is an independent of operating system here. Our next question is here, how Java made us independent of platform? How Java made us independent of platform? Let us see this. Yes, before going to this, let us see about exe file. First of all, about exe file. Exe file. So what is exe file? Let us, before that, some question here. Here's some question for you guys. Exe file, maybe C program exe file, or C++ exe file, or .NET exe file. C program exe, or C++ exe, or .NET exe file. Suppose exe file generated exe file generated on Windows OS. Okay, for example here, yes, exe file generated on Windows OS. See here, question is here, exe file generated on Windows OS. Yes, can I run on Linux OS? That is question. Yes, say yes or no. Suppose exe file generated on Windows OS. Can I run on Linux OS? Say yes or no. Yes. Answer. What is answer here? Answer is no. Yes, for this answer is no. Answer is no. What's the reason? So here answer is no. Yes, no. Yes, exe file. Yes, exe file is a OS dependent. Exe file is a OS dependent. OS dependent. Exe file is a OS dependent. So exe file is a OS dependent. Reason exe file is OS dependent here. Suppose exe file prepared on Windows OS. Exe file, yes, generated on Windows OS. Can I run on other operations, Linux or any other operations? No, we can't run. The reason exe file is a OS dependent. Reason is exe file is OS dependent. Now question is here. So why exe file is OS dependent? Now question. Why exe file is OS dependent? Why exe file is OS dependent? Yes, anyone? Yes, exe file is a OS dependent. Since it's a OS dependent, it won't work on other operations. Okay. So exe file generate on Windows OS here. Can I run on other operations? No. Other operations? No. We cannot run. Reason, exe file is a OS dependent. Exe file is a OS dependent. Now question is why exe file is OS dependent? Why exe file is OS? That's the question here. Why exe file is OS dependent? Anyone? Why exe file is OS dependent? Next question is why exe file is OS dependent? What's the reason? Why exe file is OS dependent? Yes, let us see. Exactly what is exe file? First of all, let us see what is exe file here. What is exe file? First of all, what is exe file? What is exe file? Let us see about exe file. So what is exactly exe file? Okay. See here exe file is a OS dependent. What's the reason why exe file is OS dependent? So why exe file is OS dependent? Okay. Yes, to answer this question, you must have idea about exe file. What is exe file? 1 second. Let us create one exe file. C program exe file. Yes, I'm starting Linux base. Yes. In Linux base, let us create C program exe file. Yes, this girl. 1 second. Yes, can you hear me? Deep, can you hear me? Yes. If not, please rejoin. Please rejoin. Please rejoin. Better rejoin. Is showing off. You are in offline. Yes. So you are in offline. Offline. You are in offline. Offline.
Sir, am I audible?
Yes. Hello. Yeah, this is Deep.
Sorry, sir, I am. Yeah, am I audible, sir, now?
Yeah. Who is speaking? Deep, yeah.
Yeah, I'm Deepthi, sir. Am I audible? Because I have connected via phone, not through the go-to training control. I mean, not with the audio.
Yeah, you are audible. You are audible. So, am I audible for you?
Yeah, sir. Yes, it's quite good.
Yeah, okay, fine. Well and good. But you are in offline, showing in offline. That's the reason I'm asking. Okay, fine.
Thanks for checking, but I'm not sure why it is showing.
Yeah. So what is exe file? Let us see exe file. Let us create one exe file. Say demo login. Demo login. Yes. Yes, Linux terminal. CD. mm.drive directory, present working directory, ls. See, yesterday we have created one exe file. Let me repeat the topic. ls. So what is exactly exe file? Let us see about exe file. Yes. See, present working directory m-entra in that there's a test.c. C read C program test.c. Test.c. Yes. Hash include std data byte main function int a equal 10, int b equal 20, next int c equal to a plus b, C equal to A minus B. Suppose one more statement also, let us add. C equal to, yes, A into B. C equal to A into B. Yes, next multiplication equal to, yes, multiplication is equal to displaying C value. So fine. Save and close. Yes. First compilation. Yes, what's the purpose of compilation? Checking for errors. Just it's only compilation. Compilation checking for syntax. Checking for errors. Yes, no errors. Everything is fine, no errors. Suppose some mistakes here. Some mistakes, for example, here some semicolon missing. Suppose here equal to missing here. Suppose here comma missing. Suppose here double quote missing. Suppose here semicolon missing here. Okay, suppose here comma missing. Just save, no compilation. Checking for all the errors. Okay, clear screen. ls cc 1 second rm dot to file will be removing here. ls only test.c file is there. cc hyphen c test.c sorry test.c cc hyphen c test.c is all the error right. Yes, compile shows all the errors from top to bottom. Compile shows all the errors from top to bottom. See, 9th line error, 11th line error, 13th line error, 15th line error, 17th line error. Yes, next 24th line. Compile checks the all errors from top to bottom. Okay. Yes. No spelling mistakes, it won't give the errors. So spelling mistake is not error. Okay. Yes. So you can compiler checks the all errors from top to bottom, shows all the errors. Compiler shows all the errors. Okay. No correct all the errors here. Correction of errors. Semicolon. Yes, correction of these errors. Next here equal to missing. Equal to missing. Equal to missing here. Okay. Here's a text. For text spelling mistake, no problem. That is not error. Within double quotation text message. Text message. Text message, no problem. Anyone you can write the text message. Printf means, yes, here correctly you have to give that name here. Suppose one character missing, the printf, right? There's no, don't have that such kind of function. Printf. Okay. Yes. Next here, comma missing. Comma missing. Yes. Next here, double quote missing here. Double quote missing. Save and close. Now recompile. Yes. One more error. Yes. Line number 21. Printf. Before printf. Yes. Before printf. Line number 21. So before printf. So this is line number 21. See this line 21 here showing. Yes. Here semicolon. Semicolon. So correction of all the errors. After correction, recompilation. Still one more error. So where is error? Printf. Yes, expected double quotes. Expected here. Yes, double quotes. Yes, here. Printf. Double quotes. Okay. Save C equal to A into B. Multiplication equal to personally C here. This is. Yes, subtraction is equal to. Yes, okay. Find double quotes. Yes, here comma, sorry, here double quote, here expecting here, comma. Here is error message. Okay, recompile. Yes, compiled. Now tested.o file created. What is tested.o? Tested.o is a binary code of your C program. See, this is C program. Yes, complete C program, top to bottom. Top, this is your program. Okay, see, this is the header file, that is reference. Header file is reference. This is your C program. Top to bottom converts in binary codes and write to tested.o file. So tested.o file contains binary code for your C program. Tested.o contains binary code for your C program. Okay. After that, so binary code for your C program generated. Tested.o contains binary code for C program. After that, next CC hyphen O. Hyphen O means object file, linking object files. Tested.o. So linking object files. Yes, O means object files. Yes, now exe result exe is project exe. Yes, tested.o file. So what happens here? Hyphen O option converts tested.o into project exe file. Yes, enter key ls, the project exe file created. See, at the time of creating project exe file, what happens here? C compiler checking for all the errors. If no errors, generating binary code for your C program. After generating binary code here, next hyphen O option. Hyphen O means here is a linker. This linker as a part of compiler, this is a linker. Now linker taking your C program, your .o file, your C program binary code less. Yes, in program there is a hash includes. Yes, in program there is a hash include. Hash include std avoid data header file here. This header file is also having some binary code. This header file also developed in C language. Yet that header file has some binary codes. Header file has some binary codes. Okay. Now what happens here? Now what happens when you creating exe file? What happens here? So linker taking your program binary codes plus std avoid data header file binary code plus OS library. OS library. Okay. Linking all this in finally generating the project exe file. So project exe file, finally project exe file contains what here? C program binary code plus C software library means header file binary code plus OS library. So OS library is linked to this project exe, right? Now run it. Run it here. Run it. Yes. Output got it, right? Output got it. So at the time of creation of exe file, yes, C program binary code plus next header file binary code plus OS library, linking all this generating exe file. So that exe file contains what? Binary code of C program, binary code for header files, and binary code for OS library. So OS library binary, that is complete exe file. That is complete exe file. Okay. So what is exe file? For example, yes, exe file, yes, C program, yes, C program exe file, C program exe file prepared, C program exe file prepared on Windows OS. Okay, yes, Windows OS. C program exe file generated on Windows OS. Then it contains binary code of C program, means C program binary file. Okay, C program, yes, C program binary code. C program binary code means the .o file, the tested.o file. C program binary code plus yes header file, that is header file binary code. That means C software library binary code. Yes, C software library binary code plus OS library binary code. OS library binary code here. Okay, so binaries of OS library. So binaries of OS library. Okay, yes, C program exe file. Prepared on Windows OS. C program exe file prepared on Windows OS here. Then it contains C program binary code. One second. 1 second. I'm taking some water. 1 second. Here, yes, see this C program exe file prepared on Windows OS. Then it contains C program binary codes plus C library file binary code. Header file is libraries. C library here. C library binary codes. C library binary codes plus binaries of OS library. Okay. C program binary codes. C library binary codes. Next OS library binary codes. So by linking all this, it generates exe file. C program exe file prepared in Windows OS. Then C program binary code plus C library binary code plus OS library binary codes. So OS library links with exe file, generating exe file. Yes, one more example. Suppose C++ program exe file. Prepare, yes, 1 second. C program exe file prepared on Linux OS. C program exe file prepared on Linux OS. Then it contains C program binary codes, C library binary codes. Yes, here Linux OS library here. Yes, in this Windows OS. Here first one Windows OS. Okay, so C program exe file prepared on Windows OS. Then it contains C program binary codes, plus C library binary codes plus Windows OS library. So OS library also linked with exe file. It's a static link. At the time of generating exe file itself, linking OS library to exe file is a static link. Okay. Suppose Java, that OS library linking at runtime, that's dynamic link. The topic we'll see next page. Okay. Yes. Suppose C program exe file prepared on Linux OS. Then it can C program binary codes, C program library binary code here. Yes, next OS Linux OS library. So exe file. So this first one exe file linked with Windows OS library. This second example exe file linked with Linux OS library. Similarly, one more example here. Yes, C++ program exe file prepared on Linux OS. Then it contains C++ program binary codes plus next C++ library here. Next Linux OS library. That's it here. So every exe file contains OS library. Every exe file, maybe C program exe file, hot C++ exe file, maybe .NET exe file. All the exe files contains OS library. Yeah, that is very, very important point here. Okay, so why exe file is OS dependent? Why exe file is OS dependent? Reason, it contains OS library. Yes, if contains OS library, what happens? We'll see. At runtime, what happens? We'll see this. We'll see at runtime what happens. Let us take different platforms. So first Windows platform, next Unix platform, Linux platform. Let us take 3 platforms here. 3 platforms. Yes. Let us take 3 platforms. Suppose Windows OS. Yes, Windows OS. Next hardware. See here it's a hardware. So on top of hardware, that Windows OS is running. Windows with its own library. So Windows library. Windows OS with libraries. Windows OS its own library here. Every OS has its own library to communicate with the hardware components. Okay, hardware, on top of hardware, they say Windows OS with library. Okay, yes, now here test.exe file. Test.exe, for example, here test.exe file. Yes, test.exe file prepared on Windows OS. Then it contains Windows library. Okay, right? Now test.exe file, test.exe file, test.exe file, place on Windows space. Now test.exe file, placing on Windows space. 1 second. The test.exe file, placing on Windows space. Test.exe file placed on Windows space. Okay. So you can test.exe file, exe prepared in Windows space, then it can Windows library. Now test.exe file, moving on to same Windows space. Okay, now starts execution. Test.exe file prepared in Windows space and placed on same Windows space. When you try to execute test.exe file, yes, it makes a call to, yes, this one, yes, it makes a call to, yes, just a call to Windows library, just a call to Windows library here. So it makes a call to Windows test.exe file. See, test.exe file is linked with Windows library. Test.exe file linked with exe file. Sorry, test.exe file linked with Windows library. So test.exe file linked with Windows library. Since linked with Windows library, it makes a call to Windows library. So when you try to execute test.exe file, it will try to call Windows library, call to Windows library. So call to Windows library, just a call to Windows library, call to Windows library. Yes, it's available. It's available. So once you call to Windows library, using that Windows library just communicates with the hardware components. That's it. It's working fine. Okay. So here exe file linked with Windows library. So at runtime, what happens here? It makes a call to that Windows library. Yes, Windows library is available. So same OS is available. It's available. Library is available. Then calling library, then executes and communicates with the hardware components. Fine. Okay. So since test.exe file prepared on Windows OS, yes, it's linked with Windows library. At runtime, it makes a call to Windows library. Yes, at runtime makes a call to Windows library. Yes, it's available. Using that Windows library communicates with the hardware components. Fine. Now let us take another platform. Same thing. Let us take another platform. Suppose another platform. Suppose Linux base. Linux base. So you can first one Windows base. No Linux platform. Linux base with Linux library. Okay. Next hardware. Okay. Now same test.exe file. Same test.exe file placing on Linux base and try to run. When you try to run here test.exe file, it will try to make call to Windows library, but current OS is different. Okay, test.exe file, it will try to call Windows library. Yes, it will try to call Windows library, but not available. It's not matching. That library is not matching. Now current OS is Linux library. Now test.exe file trying to invoke Windows library but not available, simply fails. It fails. It won't execute. That's the reason exe file is OS dependent. Since exe file contains OS library, it's a OS dependent. Let us take one more platform. Suppose this is like Unix base. But Unix base contains Unix library. Okay. Now test.exe file. So same test.exe file. The test.exe file. Same test.exe file place on. Sorry. Same test.exe file. Just you place on. Yes, Unix base. Same test.exe file place on Unix base. What happens here? Now test.exe file, it will try to call Windows library. Test.exe file, it will try to call Windows library. Try to call Windows library on Linux base, but not available. It fails. Okay, that's the reason exe file is OS dependent. Since exe file contains OS library is OS dependent. Okay, here question is here, why exe file is OS dependent, right? Here question is, yes, why exe file is OS dependent? The reason it contains OS library. Okay, right? Yes, it's a static link. Yes, it contains, reason is It contains OS library. Yes, it's a static link here. Static link. Static link. See here at the time of creating exe file, at the time of creating exe file, yes, OS library. So OS library links with exe file. Links with exe file. Okay. So here is a static linking. This is static linking at the time of creation of exe file itself. At the time of creating exe file, OS library links with exe file. This is static linking here. This is static linking. So this is about exe file here. Okay. So what is exe file? Yes, what is exe file? How to answer this question? What is exe file? Okay. What is exe file? Yes, simple first answer, simple answer. Yes, it is a binary code file. What is exe file means? Simple answer. Yes, it is a binary code file. It's a binary code file. Binary code file. Yes, it's a system understandable language. Yes, system understandable language. System understandable language. It is system understandable. It's a system understandable language. It's a system understandable language. Okay. Next, exe file contains. Yes. What is exe file means? It's a binary code file. It's a system understandable file. Understandable code. It's a system understandable code. Okay. Yes. It contains. Yes. Program binary code. It contains program binary code. Binary code plus. Yes, it contains program binary code. It contains, yes, program binary code plus software library plus OS library plus OS library. That is exe file. So what is exe file means? Simply our answer. What is exe file means? Simply our answer. It's a binary code file. It's a system understandable language. It contains program binary code, maybe C program or C++ or .NET CS. That program binary code. Software library means, yes, C software library or C++ software library or .NET software library plus OS library, maybe Windows or Linux, something like this. Suppose C program exe prepared on Windows OS here, then it can C program code plus C library plus, yes, Windows library. C program code, program binary code, software library, and OS library. Suppose C program exe file on Windows OS, that kind of C program code plus C library plus OS library. Suppose it is Windows OS, Windows library. So C++ exe, C++ program binary code, C++ library binary code here, and OS library binary code. That's it here. Okay. So what is exe file means? You have to answer like this. Okay, what is exe file? Now, why exe file is OS dependent? Reason it contains OS library. So why exe file is OS dependent? Simple reason. It contains OS library. So why exe file is OS dependent? Reason it contains OS library. That's the reason here. Okay. Now let us come to Java. Yes. Now this is clear, right? Yes, I think it's clear, right? Why exe file is OS dependent? I think this concept is clear, right? Yeah.
Sir, I want to ask, like OS, exe file is OS dependent, but if it is executing on like Linux and Windows, so it will run as with the help of binary code and like C programs and all. It will help through that, but it will run on Linux as well, Unix as well, and in Windows as well.
1 second. Suppose if exe file prepared on Windows OS, it run on only Windows OS. It won't run on Linux system and Unix other operations.
Yeah, I'm asking you that only. If it is prepared on Windows, then it will run on Windows. If it is prepared on Linux, it will run on Linux.
Yes, right.
Yeah.
So So what happens here? The time of preparing exe file itself, that OS library linking. OS library linking. So OS library becomes part of exe file. Once becomes part of exe file, it is OS dependent. Yes.
So, sir, then why that test.exe file is getting failed on Linux OS and Unix OS like you shown on the diagram? So why it is getting failed over here on Linux and
Yes, see
Unix?
this. Yeah. Why reason is here? See, test.exe file is trying to call Windows library. Okay.
Huh. Okay,
Example,
right.
our
Got
example,
it.
our example. Test.exe, our example is test.exe file prepared on Windows file, then it contains Windows library. Okay.
I come to know because
Means
here it is called to.
yes, test.exe file placed on Windows OS. Now it will try to call Windows library, but it's not. Yes,
Huh.
it's always simply calling, then executes, generating
Yeah,
output.
yeah. Okay.
Same test.exe file prepared on Linux base, right? Now it will try to call Windows library, but not available, right? So you can
Yeah.
test.exe file linked with Windows library. Since linked with Windows library, it will try to call Windows library, but not available. The library is not matching. Not matching simply fails. I think clear, right? Okay.
Yeah, if it will test.exe file calls to Linux library, so then it will run.
Yes, it will run. Right. It will run.
That was my point. Thank you so much.
It will run. It will run.
Yeah.
Because test.exe file is linked with Linux library, then it will run a Linux base.
Yeah, that is only the point.
Yeah, suppose test.exe file prepared on Windows base, running a Linux base, it won't because that
It
library.
won't run.
Okay.
Yes, sir, got it. Yeah.
Anything with Unix library cannot share. You say yes. exe file is a OS dependent. Exe file is always OS dependent. Okay. Now let us come to Java. So what is? Let us see same thing Java here. Let us come to Java. So what is happening Java here? Let us see Java. Yes, in Java here, after compilation generating dot class file. Java, yes, everything is dot class file. So in Java, everything is dot class file. Yes, dot class file. So runtime is always dot class file here. Okay, in Java, yes, runtime is a dot class file. Runtime is a dot class file. Now question is, what is dot class file? What is dot class file? What is exactly dot class file? So what is exactly dot class file? So dot class file, simple answer here, dot class. Dot class file is a bytecode file. Bytecode file. It's dot class file is bytecode file. Bytecode file. So what is exactly bytecode? We'll discuss next. Dot class file is a bytecode file. Bytecode file. Yes, it contains what? It contains Java. Yes, Java program code. Java program code plus Java library. Okay. See, in case of exe file, yes, in case of exe file, yes, program code plus library plus OS library. There are three things. There are three things here. Okay, that exe file contains, yes, exe file. Exe file contains three things here. Exe file contains what here? Yes, program code, your program code, plus that application software library here, plus OS library. Okay, program code plus your library here. C program code, C library. C++ program code, C++ library, plus OS library. When come to Java here, Java dot class file. Dot class file contains Java program code plus Java library only. That's it. No OS library. Okay. Dot class file. Dot class file. See, dot class file. Dot class file does not. Yes, does not contain any OS library here. Does not contain any OS library here. Dot class file does not contain. Dot class file does not contain any OS library. There is no OS library here. Okay. Dot class file does not contain any OS library here. Okay. Yes, there is no OS library in dot class file. So dot class file contains only Java program code, Java library. Okay. So dot class file. So dot class file is a bytecode file. See, it is not a prepared file. Dot class file is not a prepared file. Is not a prepared file. Prepared file. Okay. Dot class file is not a prepared file here. Dot class is not a prepared file. Okay. Suppose if it is exe file, yes, exe file is a prepared. Yes, prepared file for specific ways, for specific ways, for specific ways. Okay. So here specific ways. Okay, exe file is a prepared file. Exe file is a prepared file. Okay, dot class file is not a prepared file here. See here. See dot class file is a byte code file. Dot class file is a byte code file. Yes, exe file is a binary code file. Exe file is a binary code file here. See here, dot class file is a byte code file. Yes, exe file is a binary code file. Okay, next. Yes, dot class, yes, is not a prepared file. Dot class is not a prepared file, but exe file is a prepared file for specific ways. Okay, now dot class file. So dot class file, it contains Java program code, Java library only. A dot class file does not contain any ways library. Okay, does not contain any ways library. Now, how the Java program is working? Let us see. Let us take same platforms. Yes, let us take Windows platform here. Windows platform. Let us take Windows platform. Windows platform here. Yes, tested dot class. After comparison, result file is tested dot class file. How this is running here? Tested dot class file. Now this tested dot class file placing on Windows base. Test dot class file. Now this dot class file don't have any library. Now, how this running here? Not tested dot class file, just tested dot class file. Tested dot class file moving on to Windows library. Sorry, Windows base. After moving on to Windows base, it has run here. Yes, to run any program that has to link with OS library compulsory. To run any program, that program should be linked with OS library. In previous class, we discussed every application software, every program, maybe C program or Java program or Python. Every program has to link with OS library before going to run it here. So before going to start running here, that has to link with OS library. Otherwise, cannot communicate with hardware components. To run any program, that program first of all it has to link with OS library. Once linked with OS library, communicates with hardware components. Every program has to link with OS library. So every program, maybe Java program or maybe C program or C++, every program has to link with OS library to communicate with hardware components. Suppose if it is C language, what happens here? At the time of creation of exe file itself, that OS library linking. Okay. Yes, all exe files like C program exe, C++ exe, .NET exe files, all the exe files linked with OS library at the time of generating exe file is static link. At the time of generating exe file itself, yes, linking at runtime placing here. That's called static linking. Yes, in Java, what happens here? Dot class file. What is dot class file? Dot class file contains only Java program codes, Java library. That's it. There's no OS library. Now this dot class file placed on Windows OS, try to run it here. Now this dot class file should be linked with OS library here. At runtime, this dot class file has to link with OS library. Then communicates with hardware, right? Let's get dynamic linking here. Who links it? See, in C and C++, at the time of creation of exe file itself, library linking. But in Java here, that OS library never links with dot class file. Dot class file is not a prepared file. It is not a prepared file. Okay, now dot class file contains only purely Java program. Yes, your Java program plus Java library. Java library also developed in Java. Here. So dot class is a purely Java program. Yes, is not linked with OS library. Then how it executes? If you execute this tested dot class file has to link with OS library here. Who will link it here for this JVM? So between dot class file and OS, another layer called JVM. Now JVM comes to picture. JVM. So between dot class file and OS, they say JVM. Not JVM, right? JVM. Now what happens here? So once you dot class place on this platform. So once you place on this one here, Once you dot class file moving on to Windows OS, dot class file. Now this dot class file is given to JVM. Now JVM links with OS library. So once linked with OS library, then executes and generating output here. Okay, so dot class file placing on Windows OS. After moving on to Windows OS here, Windows JVM taking dot class file and links with OS library. So what happens here? Before going to run, just link with OS library, then running here. It's a dynamic linking. Means at runtime linking this. See, if it is exe file, this is static linking. Static linking at the time of creation of exe file itself, linking all the OS library. But in Java, what happens here? In Java, what happens? In Java here. In Java, what happens here? Yes, at runtime. At runtime here, before going to run the program here, the tested dot class file, yes, links to OS library by the JVM. So JVM taking your dot class file and links with OS library. Okay, dot class file is not a prepared file. Yes, after moving on to your system, after moving on to Windows OS here, now Windows JVM taking dot class file links with Windows library. Once linked with OS library, then execute starts generating output here. Fine. So JVM takes care of linking your dot class file with Windows library. Okay, right? Yes, let us take another platform. Yes. The session recorded. So tested dot class file, first of all, moving on to Windows OS. After moving on to Windows OS, here this is JVM. That Windows JVM taking tested dot class file links with Windows library. Just links with Windows library. So once linked with Windows library, then executes generating output. Okay. Yes. So tested dot class file. So JVM taking tested dot class file. JVM, one second. This one more guy. Yes, struggling to join. Yes. Now tested dot class file. Moving on to Windows OS. After moving on to Windows OS here, so JVM taking tested dot class file links with Windows library. So once link established here, the executes using output. Now let us take another platform. Yes, Linux platform. No Linux platform. Linux base. Now what happens here? Now test same tested dot class file moving on to Linux base. After same test dot class file moving in Linux base. After moving into Linux base, tested dot class file given to JVM. JVM links with Linux library. Once linked, yes, communication to hardware. So JVM takes care of linking with OS. Yes, is a dynamic linking. That link happens at runtime. Okay. So Java, it's a dynamic linking. C and C++, exe file. In case of exe, it is static linking. Statically linking here. Here is a dynamic linking here. Dynamic means at runtime, depends on OS. Depends on OS that linking takes place. Okay. Yes. Here, if it is Windows OS, JVM links your dot class files to Windows library. Suppose if it is Linux based, JVM links your dot class to Linux library. Same thing if it is Unix, links to Unix library. So JVM takes care of linking your dot class files to OS library. So once linked here, communicates with the hardware, then executes generating output here. So JVM makes the Java program as independent platform. That's it. So by end of this is JVM. Okay. So here the JVM. So JVM links with OS library. So once linked with OS library, then executes giving output. So JVM takes care of linking your program to OS library. So JVM is responsible to make the Java program as independent platform. Dot class file is not a prepared file. Dot class file is not a prepared file. Okay. So before going to run the program, JVM links your dot class to OS library. Once link established here, then yes, executes giving outputs. So behind of this is JVM. JVM takes care of linking here. So JVM is responsible to make the Java as independent platform. That's it. Okay. Yes. Now here dot class file is a independent platform. Java program is independent platform, but JVM is OS dependent. JVM is exe file. Actually, JVM it's exe file. JVM is exe file. See, if it is exe file, OS dependent. See, dot class file is not exe file. Java program is independent of OS, but JVM is OS dependent. JVM is OS dependent. Windows is having its own JVM. Linux having its own JVM. Next, Unix having its own JVM. So every JVM has, every OS has its own JVM here. Okay, every OS, this is for every OS there is separate JVM. For every OS there is separate JVM. Now question is here, from where JVM getting? JVM, is it part of OS? JVM, is it part of OS or not? 1 second. Yes, let me take some water. Yes, JVM. JVM, is it part of OS? No, it's not a part of OS. Once JDK installed, generating JVM automatically. JDK you have to install it here. So once JDK installed, JVM generating automatically. So here JVM is a OS dependent. Since JVM is OS dependent, JDK is OS dependent. JDK is OS dependent here. See JDK. For Windows, it's separate JDK. For Linux, separate JDK. For Unix, separate JDK. For Mac OS, another JDK. So JDK changes from OS to OS. Yes, you have to download separate JDK for every OS. Yes, you have to download different JDK here. JDK changes from OS to OS. JDK changing from OS to OS. Java development kit. So once JDK installed here, JVM get installed automatically. JVM is a OS dependent Java virtual machine. Java virtual machine. It's a OS dependent. So JDK always is a OS dependent. Okay. JDK for Windows OS, JDK for Linux OS, JDK for Unix OS, JDK for Mac OS. So depending on OS, that JDK changes. You have to download separate JDK and you have to install. That's it. So this is about independent platform. So behind of this, there is a JVM. So JVM makes the Java program as independent platform. Yes, in Java, dot class file is not a prepared file. Yes, at runtime, before going to execute, preparing according to current OS, then executes. That's it here. It's a dynamically linking. Okay, C and C++ exe file is static linking. Okay, exe file at the time of generating exe file itself linked with OS library. That is statically linking here. That is statically linking, but it's a dynamically linking here. That's it. So that's the reason. Yes, that's the reason Java program is independent platform. Yes, so this is reason behind of this. Java program is independent platform. Next, portability, other features, we'll see next class. Okay, that's all for today. Yes, any doubts? So next class we'll go for Java installation. Yes, yes, other features matter of half an hour only. Other features like portability, oops language, scalability, security, just matter of half an hour. After next 45 minutes, we'll go for Java installation and Java setups and Eclipse setups. Okay, so next class we'll see. Right? Yes, any doubts?
No, sir. No, sir.
Yeah. So thank you. Yes, we'll continue tomorrow. Tomorrow taking class. We'll continue tomorrow. Right? Yeah. Thank you. Yes, see you tomorrow.
Okay, sir. Thank you.